Most operations in mathematics are reversible. So you have a way of changing an equation, and then you have a way of changing it back to how it was. And what we're going to look at today is how we both expand sets of two brackets, and then how we can go from the quadratic equation that we have back to a situation where we have two brackets. Let me show you what I mean. If I take an example like x plus 2 times x plus 4, that means this whole thing times this whole thing. And the way we do this is we do it a bit at a time. So x times x is x squared. Then we have x times the 4, it's a plus 4, so it's plus 4x. Then we have the 2 times x plus 2x. And then we have the 2 times 4, which is plus 8. Notice in this case both of these are pluses, which leaves us with no problems over here with negative signs. And we can simplify this a little bit further. So we've got x squared, 4x plus 2x is plus 6x plus our 8. So we would write down x plus 2, x plus 4, which is our original expression, equals x squared plus 6x plus 8. This is a quadratic expression. It's called a quadratic expression because we have this square term in it. So where we have an x squared and it's the highest index in the equation, it's a quadratic. I'll give you another example. X plus 2, x minus 4 this time, just to show you the difference. So we do x times x, which is x squared. X times minus 4 this time is a minus 4x. 2 times x, and it's a plus 2x. And then we have plus 2 times minus 4. 2 times 4 is 8. Because one's a plus and one's a minus, it's a minus. And again we can simplify this into x squared. We have minus 4x plus 2x. So we take away 4x, we add back 2x, which gives us the minus 2x, then minus 8. So x plus 2, x minus 4 equals x squared minus 4, 2x minus 8. Here's a couple for you to try. Notice I've given you the more difficult ones because I've left you with ones with minuses in. So stop the video and work out those two quadratic expressions for me. Okay, we've done that. Let's go through this one very quickly. X squared plus 4x minus 2x minus 8. Bring those terms together in the middle. X squared. This time it's plus 4x minus 2x because it's plus 2x minus 8. So x minus 2, x plus 4 equals x squared plus 2x minus 8. And this time x squared minus 4x minus 2x, and this time it's minus 2 times minus 4. So the 2 times 4 is 8. The minus and the minus make a plus. So we get x squared minus 6x plus 8. So x minus 2, x minus 4 is equal to that. I'm just going to put some lines around these so we can see these a little bit clearer, because we're just going to look at these in a little bit more detail. Now, first thing I would say to you, when you're doing these, always draw the lines. Don't just draw the lines and then write the things down. As you go through, as I did, for each term, draw the line, write down the term. Draw the line, write down the term, and so on. This will almost guarantee you won't forget what you've done and what you haven't done. So not doing that is a sign that either you are a brilliant mathematician and you can do these all in your head, or that you're being a little bit too lazy and you're going to get them incorrect at some point. Now let's look at these ones that I put the squares around. If we can start to see a pattern here, the first thing we can see is that every single one of these has an 8 at the end. Sometimes it's a -8, but it's still an 8. The reason that that's an 8 is you've got this 2 and this 4. The 2 and the 4 multiplied together give the 8. And whether or not it's a plus or a minus, or a minus and a plus, or a minus and a minus, determines what the sign is. So this number here at the end is always that times that. Look at the number in the middle. This time it's a 6 because we've got a +2 and a +4. +2 + 4 gives us 6. This time it's a +2 - 4. +2 - 4 gives us -2. Here we've got -2 + 4 gives us a +4. And here finally we've got -2 - 4 gives us -6. So this term we add, and in this term we've got the multiply. So we can use this pattern to work out what to go from this equation back to this factorized version. So if we can go from here to here, we will say that we factorise the quadratic equation. Let's see if we can look at some examples of this. If we take x² plus 5x plus 6. Now, this is very straightforward. We know that this is going to end up looking something like this. We're going to have two pairs of brackets. They're going to be multiplied together, and it's going to be x plus or minus something, x plus or minus something. Now, in this case, as before, both of these are pluses. This is our first example we did, remember? The first example here we did. First example we had two pluses, and we ended up here with a plus and a plus here. So we can usually say that if we've got a plus here and a plus here, then both of these are going to be pluses. Makes our life a little bit easier. So let's just put a plus in there, make our life easier. Is this number times this number? I'm just going to put a number in here. I'm going to call that A, and I'm going to call that B. We don't know what they are yet. So A times B equals 6. So that could be 1 times 6, or 2 times 3. Could be 3 times 2, doesn't matter the other way around. So it's got to be one of those possibilities, isn't it? We also know from our previous workings, do we not, that this number plus this number is equal to this number. So in this case, A plus B is equal to 5. Which of these sets of numbers, when we add them up, add to 5? Well, that doesn't, and it could be either of these two. Because they're both pluses, it doesn't matter whether it's 2 times 3 or 3 times 2. So we can actually put in here our solution, x plus 2, x plus 3. So we have factorised this equation very simply to get that solution. And if we expand this out to prove that, x squared plus 3x plus 2x plus 6 we can show that they're exactly the same. Let's try another one, this time one that's got minuses in. X squared minus x minus 6. So that equals, we've got, going to end up something like this, isn't it? And we've got this number here, and if that's A and that's B, A times B equals minus 6 this time. Now this time it's going to be minus 1 times 6, or 1 times minus 6, and it's going to be 2 times minus 3, or minus 3 times 2. They would all give minus 6. But we also know that A plus B is equal to, and I've missed out the 5 over here, no I haven't, A plus B equals minus 1. So, which of these sets of numbers, when you add them together, make minus 1? Well, minus 1 plus 6 is not minus 1. 1 plus minus 6 is not minus 1. 2 plus minus 3, that equals minus 1. So our solution here is x plus 2 x minus 3. So x squared minus x minus 6 is x plus 2 minus 3. Sometimes you can see this straight in your head and you don't need to write all this down. And in these cases I think you probably would have seen this straight in your head. But it's worth doing this just to get used to the idea. So here's a couple for you to try. Can you work out what the factorisation of this is? So it's going to equal x like that. And secondly, x squared minus 9x plus 18. And see if you can do those for me. Okay, how do we get on? Let's have a look at this. So, two numbers that multiply together to give 10, 1 and 10, 2 and 5, and that's it, and they work the other way around equally well. Add together to give 7. Well, only one of these adds together to give 7, so we've got plus 2 plus 5. So they multiply out to give together to give 10, and they add together to give 7. This one's a little bit more difficult. Look, we've got a minus sign and a plus sign. Here's the thing, if this is a plus and this is a minus, then both of these numbers are minus numbers, because the minus times a minus equals a plus, and then they add together to make minuses. So two numbers that multiply together give 18. Which of those pairs of numbers multiply together to give 9? Sorry, multiply together to give 18 and add together to give 9. Well, it's got to be the 3 and the 6. As you can see, they multiply together. 3 minus 3 times minus 6 gives us plus 18. Minus 3 plus minus 6 gives us minus 9. And you can multiply that out to check that the answer is correct if you wish. And that's how to factorise.